Hello and welcome to 4 Sevens, a podcast hosted by Alex Box from mathsplay.org and Marissa Cashmore from Motivating All Maths Learners to Succeed. 4 Sevens is a 7-part series exploring and sharing different ways to learn maths through play.
The International Day of Maths is a global celebration of mathematics that falls on the 14th of March. In 2024, the theme will be Playing with Maths, and so we thought what better way to support this important theme by bringing together a range of maths teaching and learning professionals to share and discuss playful, positive and powerful ways to engage and connect with mathematics.
We hope that, when listening, you find the conversations valuable as we endeavour to inspire you with a range of stories, perspectives and many practical ways to explore and play with maths.
Before we get stuck into the episode, we'd like to acknowledge Aboriginal and Torres Strait Islander peoples as the traditional owners of the lands on which this podcast was created and is being listened to. We pay respect to elders past and present and recognise the contributions of all First Nations peoples to the land we live, learn and play on.
In this episode, we chat to founder of mathsplay.org and host of 4 Sevens, Alex Box. Alex takes some time out to chat to us about number talks and some careful strategies we can use to support students to develop and share their mathematical thinking. As someone who identifies as formerly maths anxious, number talks are, in no small way, responsible for helping Alex discover a love of mathematics and of teaching maths. On her quest to develop and refine her own practice, she has developed some useful resources which we will link to in the show notes. Alex has become a key inspiration and valued friend in my life and probably many others as well. Thank you, Alex, for taking some time out to have a chat to us today.
Hello, thank you.
Welcome. All right, so we're going to get stuck straight into the menu, and it's like any other podcast. We're going to go through an entree, some main meals, and then the dessert at the end. So we're going to start off with a little bit of information about you, Alex. What has led you to focus on your current role? Tell us about your background. Go.
Well, yeah, I guess my journey, like many others, there's a bit of serendipity playing a role. So I was an undergraduate arts student majoring in Indonesian, and in my final year I had to write up an article about something that was going on at a local level in Indonesian. So I just reached out to the primary school that I went to as a kid, where my mum was still working in the library, and interviewed the principal about their SunSmart program. And at the end of the interview, Robin, the principal, asked if I'd be interested in a job as an integration aide. I took that on and worked in a Year 6 class and had a great time. And within a few weeks, I thought, oh, this is the environment that I'd like to work in. So I then organised to do a graduate diploma of education, and then that led me into primary teaching, which I loved. And then after about 10 years in the classroom, took a sabbatical to recover because it was very demanding, or at least for me it was. And when I was travelling, we stopped off for a week in San Diego and I visited some schools there called the High Tech High Cluster. Yeah, so I visited the 3 elementary schools, and they're known as tech schools, so very hands-on integrated projects. And at the end of each trimester, they have a exhibition. So they have this authentic audience to present their learnings to. But I just happened to stumble on a regular Year 3 maths class. I walked in on a lesson where they were running cognitive guided instruction, solving a worded problem. The vibe was different. The formula for teaching was different. It was refreshing. It was like something that I wanted in my teaching toolkit, but I'd never seen it before. And that it was just a matter of asking a few questions on that day, like, oh, what is this pedagogy? And I was directed toward ucube.org, which I'd never heard of, Joe Bowler's Mathematical Mindset book, which I then devoured within a week. And that was part of my own, reflection of, oh, wow, the problem wasn't actually me at school. I just didn't have access to this open-ended, creative, social maths experience that I've witnessed in this class on the other side of the world. So then I spent the next 6 or 7 years continuing to learn more and more and repairing my own relationship with mathematics. now that I have the strategies and the positive ideas about what it means to be mathematically successful.
That's such a beautiful story. How did it feel, though, walking into a classroom that has such creative social maths experiences? How did that make you feel in terms of what you experienced in school?
Well, to be honest, I was excited. I was just really excited to see something that felt right. Yeah, it's all interesting, and I just enjoy opportunities to play with mathematics and learn from others and share some of the things that I've been able to learn from people that are doing really important research. For instance, in the area of number talks, I consider myself a student of Ruth Parker, Kathy Humphries, and a few others.
Yeah. I think that's a lovely entree into our main meal. Let's get started. So let's talk about maths talks. What is a maths talk?
I mean, mathematical talk is embedded throughout maths class, and there are a lot of wonderful resources and texts that are supporting teachers to do this skillfully and thoughtfully, to orchestrate mathematical discussions in productive and positive ways. But a maths talk I think of as a gathering of a group together to consider a mathematical prompt or visual and talk about it. So this could be anywhere from a notice and wonder discussion where you might have a beautiful I love using an artwork that I saw in Newcastle. It's a grid of 25 squares, and it's a beautiful one to pose the question pair, what do you notice, what do you wonder? Because there's just so much maths in it. And students, and I've run it with teachers a few times too, they're noticing all kinds of things from square numbers, how many squares, so there's sort of problem solving of coming up with a way of counting all of the squares within the 25 square grid. There's vocabulary coming out such as area and perimeter, fractions and percentages come out in terms of the proportion of colour. So it's a really lovely opportunity to invite all manner of ideas, to allow everyone to take part in the discussion. I think that's probably one of the most important things with these open-ended talks, where there is actually more than one correct answer, because of course you could notice any number of things, you could wonder any number of things. And it's a wonderful place for people to be heard, to connect to mathematical ideas. And as the teacher, you can be really strategic about how you use the prompts that you use. So that particular prompt, and I will link to it because it's a lovely visual that might be interesting for people to see.
Yeah, awesome.
And maths talks are often used as a way of sparking a whole class investigation. So for instance, for that one, it might well be that my intention is to run a problem-solving lesson, which is what are some ways that you could count the number of squares, or maybe there is some other geometry concept that I really want the students to explore, but I can use that maths talk as a way of getting everyone engaged, activating their prior knowledge, getting vocabulary coming out, and really just having a lovely social conversation that's centered around mathematics. So you can have your really open-ended conversations like that. What's the same, what's different is another example of a maths routine that you can run as a whole class maths talk, where students are looking at 2 items. It might be a 10 frame with 10 dots, and it could be 10 dots that are scattered on the other side of the slide. And students are looking at, okay, what's the same, what's different? It's an authentic opportunity for them to do some counting, to think about the shapes that the 10 frame is making, if that's not vocab that they already have. If it is vocab that they already have, then that can come out and it can be a review. So, that might be an example of an open-ended maths talk that happens in Prep or Year 1. There are a whole bunch of other talks like that. Which One Doesn't Belong is a beautiful one as well.
Yeah, that's coming to mind for me too. And
it's lovely because typically in Which One Doesn't Belong, we have 3 or 4 different items. It's been very carefully designed so that when you compare and contrast, there are going to be things that each pair of items has in common, or each group of 3. If you've got, say, a $1 coin, a $2 coin, 2 $1 coins, and 4 50-cent coins, the 50-cent coins might be the one that's the odd one out because they're the silver coins. The $1 coin might be the odd one out because it's the only item that doesn't make up $2 in total, for instance. So these opportunities to apply mathematical understandings, review ideas like what coins are worth, for instance, but in a way that is also practicing other mathematical skills like mathematical argumentation, and a really playful space to do that.
Yeah. The terms, what is it? Convince yourself, a friend, and a skeptic come to mind for that one. Yeah.
And again, it's open-ended because there's more than one correct answer. And in all of these talks, there's this undercurrent or this idea that we can keep going. It's not just once you've found one idea, that's it. So if you find one item that doesn't belong, in which one doesn't belong, and you've got your argument as to why, maybe you could then find another argument as to why for that item, or you could consider one of the other items and think about what might make them the odd one out. So the idea of maths as being done is challenged through these discussions as well.
Yes, yep. So we would love our listeners to jump on, because we're going to add some maths talks to the show notes, and they can hopefully add some ideas and thinking to that as well, which would be awesome.
So those are a few examples of open-ended maths talks, because they do have multiple correct answers, and they can, even though as the teacher I might make sure there's a particular mathematical idea that comes out for my teaching focus, but there's this space for students to do lots of sharing and own that conversation. And then, of course, you've got number talks, which they're not open-ended to the degree of you can have multiple correct answers, but they have this open middle. And it's really been designed to help build and cement foundational number understandings. I may have gotten ahead, so if I have, then you need to ask me a question.
No, that's okay. Well, the next question was going to be, what are number talks, which you've just spoken about, and how are they different to maths talks? Is that they're not...
Well,
go.
Yes. So I would consider a number talk a type of maths talk. It's what makes sense to me is having a maths talks as an umbrella, where students come together as a group and they have a conversation about a mathematical prompt. And I guess because mathematical talk is going to be a part of most maths learning experiences, I guess the difference between your embedded maths talk in, say, a hands-on investigation or other work would be that it's a coming together to connect with a mathematical visual and have a social discussion. So it's a rule that I have for myself is to make sure that there is time for admin-free maths. And by admin, I mean like the pencil and paper, because I do think there's this idea that when you're doing maths, you always need pencil and paper, but there's something very empowering about being able to think on your feet. And that's one of the things that number talks run regularly over time too, because they focus on building mental computation skills. So being able to add numbers, take away numbers, work out your change on the fly, those are all things that you can do when you've got that kind of number sense. It's probably worth mentioning that dot talks play a really, really important role. So a dot talk is a type of number talk. It's where instead of having a arithmetic problem like 125 plus 98, we have a selection of dots. I will link to one or two videos of a dot talk in action, because I think that's one of the most powerful ways is to learn about an approach is to see it in action. But Kathy Humphries and Ruth Parker, who've written two of the books that I love the most about number talks, they point out that everyone has ways to see dots on a card. And by running dot talks before moving to written arithmetic problems, students, they'll take up the challenge of seeing a selection of dots in multiple ways. Of course, a dot number talk is going to look different across the ages. So in foundation, it might be a sequence of dot cards with one or two dots on them at the start of the year. Whereas in grade 2, it might be a couple of 10 frames and then a few extra dots, and getting the kids to come up with different ways of counting those. And then in, say, year 3 and above, like all the way up to year 12, it might just be a matter of a few free dots and getting the students to look at them and share in different ways. I have written an article for Prime Number about getting started with dot talks in the classroom, so I'll link to that. But once a class is familiar with the routine, because a number talk is quite different to a lot of other forms of maths instruction, and maybe I'll just walk through the format. So let's have a think about an arithmetic problem now. So imagine that I've written 25 plus 23 horizontally on the board. So horizontally is important because if we write it as a vertical algorithm, then that's telling the students that we expect them to solve it in one particular way. But by writing it horizontally on the board, it opens up the opportunity for students to come up with their own ideas. And this is where we're actually tapping into that creativity. Students actually are generating their own ideas. They're using what they know to come up with a solution. And then they're given think time. And the think time is really important because we really want to change that narrative about speed being the hallmark of success, or one of the major hallmarks of success. So students are given time to mentally play with this problem of, what was it, 25 plus 23,
Yeah.
I think. And they do that mentally, and it's really nice quiet in the classroom. And students are invited to have a solve of this problem in your mind. If you come up with one way of knowing the answer, see if you can find another way of knowing the answer, and notice whether you get the same answer each time. And what I really like about that is it's normalizing mistakes coming out. And it's encouraging students to check their work by using mathematical reasoning. And that's essentially one of the jobs of number talks. In addition to focusing on foundational number understandings in an ongoing way, so things like trusting the count, place value, important number understandings that we know a lot of students are getting to high school without.
Yeah.
It's also supporting them to create a habit of reasoning when they're crunching numbers, when they're playing around with problems, so that they can have confidence about their answers. If they can use the reasoning, then they can have confidence.
Yeah.
So that first bit is really important. They have this time to think, and I've gotten to a point where I've structured a number talk in my mind as, so think time and then the main talk. And the main talk is where, after enough think time, the teacher has a sense. Some classrooms use hand signals to demonstrate that where they're at with their thinking. The teacher then invites students to share answers. So it's important to break up the answers and the solutions step. I realised this, I tried merging them together, and I think you can probably do that with younger kids. Maybe it's necessary to do that with younger kids, is just have kids sharing their answer and solution together. It's going to depend on the group, and it's going to take time to develop any routine. But one of the reasons I learned from the experts is that by separating the answer sharing stage, it's more likely that you will get multiple answers come out, because if you invite students to share their answer and their solution one at a time, and someone shares a solution where the answer is clearly the answer, then it minimises any other students sharing mistakes. And yeah, it's the world of mistakes and normalising them. Number talks done frequently and well and in a really nurturing way can really build curiosity around mistakes and really help to make them a thing that's just a part of the mathematical process and not something to have shame around.
So can I jump in there? If you were to ask the question 25 plus 23, and I've had a go at doing it, would you then say to me, what answer did you get? And I would say 48. And then would you say, what would you do then for the rest of the students? Would you then ask me to share, or would you go, no, I want to hear other answers first?
Yeah, so coming back to the stage, the main talk, first we collect all answers. So I'd say, who's ready to share what answer they got? And you might pop your hand up and say, I got 48. Did anyone get a different answer would be my next question. And we just collect answers until there are no different answers.
Yeah.
And sometimes you only get one answer and that's fine. But I think what's really important is that as the teacher, you communicate that there is an expectation that often there will be more than one answer. And that's part of the normalizing of the mistakes. And so over time, hopefully that message, along with all the other conversations and the maths pedagogies that we're using to celebrate struggle and challenge students in a way that they can also have success. And then the next part of that main talk is sharing the solutions. And this is really the juicy part. This is the really exciting part, because it's where we, the teacher and the students, get to hear how others are thinking. As a teacher, we need to know where students are at, and this is a great opportunity to learn a bit more about how they're thinking. But the students as a group get to benefit from each other's ideas as well. So to come back to your question about would I invite people who shared an answer to defend their answer or to explain how they got the answer, I personally don't do that. I would just move from the answer collecting stage to who's ready to share how they got their answer.
Yeah.
I really have developed an appreciation for the language of readiness. Who's ready?
Yeah.
Someone pointed out to me once when I was running a number talk a few years ago now, I was using the language, who's willing to share your answer? Who's willing to share your approach? And this colleague pointed out that the word willing kind of communicates the message of it's something that might be a bit daunting or difficult.
Yeah.
And so as a result of that, I thought about the language, and that's the reason why I've moved more to, who's ready to share? Because just because you're not ready now doesn't mean you won't be ready later. But I think the language communicates that it's less of a big deal to share your ideas, if that makes sense.
And I think it's really important to ask and invite rather than just pointing out and going, Simon, how did you do it? Rather than pointing out, it's so important to ask the question as to who's ready and give and sort of invite them in, isn't it?
Yeah, I know there are differing opinions on this, but I keep going back to the texts of Kathy Humphries and Ruth Parker, and I believe there's another Kathy involved in the creation of Number Talks many, many years ago, like 20 plus years ago. And they were created as a routine to do certain jobs. And one thing that's really key to the job of building number sense and developing confidence when crunching numbers is it's got to be safe. For me, when someone tells me to do something, it gets my back up.
Yeah.
But then there's also a favourite tweet I love because it speaks to this so well, and maybe I'll link to it, but off the top of my head, it's a guy was called upon to answer in class, and after a pause, he said, "I'm not stupid, I'm just panicking." That really spoke to me because I, as someone who has struggled with social anxiety, so it's not even just maths anxiety that we're talking about here. There's also social anxiety as a consideration, as well as a whole bunch of other things that we probably don't even have expertise in. And so to just assume that everyone should have an answer and to share at a certain time, I think it not only can be problematic and stressful for individual students, but it's also going to actually affect the quality of the discussion for the whole class as well, if we're inviting people who haven't even had the chance to decide that they're ready to share. I think it's important to develop confidence in students to share their ideas. I use approaches that are different to cold calling particular students.
I think that brings us to our next question beautifully. I discovered TalkMoose when I was first working with my primary maths specialist cluster led by Leonie Anstey. Since then, it has become a regular, consistent approach I use in my maths teaching routines. And I like the way you mentioned that it can be isolated or it can be used as a bit of a warm-up prior to a teaching a concept and retrieval as well. But in an example being, you pose a question such as a number talk problem, like how many dots or 28 take away 12. You provide some thinking time, wait time, And then how important do you consider talk moves to be when it comes to number talks, and why are they so important?
Well, there's a nice poster by the New South Wales government which has the talk moves, and it presents them really nicely in that it explains each of their purpose and also what it might sound like in the classroom. And having a look at that poster, which we'll also link to, a lot of these are a part of a number talk. So the wait time, I already talked about the importance of that. And something that I'm trying to do is not just limit the use of wait time to that initial sense-making time at the start, but also when I ask, okay, who's ready to share their solution, actually stopping and waiting and giving students time to decide whether they're ready and put their hand up. Turn and talk. It's interesting because when I first started using number talks, I used turn and talk at the start of a number talk. So, for instance, after the think time, before I invited solutions, I'd get the students to turn and talk and share their ideas. And I thought this was a good idea in that it allowed everyone to share. It allowed everyone to share, which I felt was a good thing. And then it also would allow me to eavesdrop as well on different conversations so that I could think, that they've used this strategy and I really want to make sure the whole class gets to benefit from that. And then I read the sequel of Ruth Parker and Cathy Humphries. So they wrote the book Making Number Talks Matter, and then they wrote Digging Deeper, Making Number Talks Matter Even More, where they revisited their approach after further research. So they just adjusted their recommended number talk structure. And they also responded to different practices that emerged, like having turn and talk at the start of a number talk before sharing. And one of the things they found was that the quality of the strategy shared, or the eagerness of students to share, dropped after having turn and talk at the start. So it's something that got me thinking about, okay, so when do we use turn and talk? And in the same book, I'm pretty sure the idea was presented that how about you do turn and talk after that main sharing? So coming back to the structure of the talk that I use, I've got the think time at the start. You've got your main talk where you're inviting the answers and the solutions. And the teacher, by the way, is recording these on the board in probably year 1 and above. In prep, it can look a little bit different. Just again, it's just going to depend on the group. So once you've finished recording different solutions, then there's this third and final stage, which is more talk. And I love this because after you've collected, say, 3 to 5 different strategies on the board, this is an opportunity for everyone to think and do some more sense making. They've got some stimulus on the board now. They can step into an analysing and evaluation role. It might be that the teacher simply asks students to have a look at the different solutions and say, what do you notice? What do you wonder about this set of solutions? So an open-ended question. It might be, what surprised you in this discussion? Or it might be, can you find two solutions that are a bit similar but are a bit different? So something open where they, again, have time to look and think. So the think time's there. And then have an opportunity to turn and talk. That's where I quite like using turn and talk, is in the more talk, where they have an open-ended question, analysing or evaluative. It's not expecting them to have an answer. It's something that everyone can take a part in, and it's also practicing some higher order thinking. So turning and talk and then sharing ideas from that. And that's going to take you through to your, 7 to 15 minutes by the time you go through those 3 phases.
Beautiful. Awesome. I've got a couple more questions for you before we get stuck into our dessert menu, because I'm feeling pretty full, but I've just a couple I'd like to squeeze in. I'm really happy and proud and seeing so many different maths educators or education authorities and that they are endorsing and encouraging the use of number talks in maths classrooms. It seems to be a practice that many classrooms are taking on. Once they have the opportunity to learn, though, about them and see the value, which is why we've done this podcast today as well. Given how different the approach might be for practitioners to get used to, do you have any advice around how to implement them?
Well, first of all, like I said earlier, running dot talks to start with is really powerful and a lovely way for both the teacher and the students to ease into a routine that starts with students, starts with them and their ideas. And it's a really nice way to make sure that the prompt will be accessible to everyone. I think that's one of the challenges, is making sure that the question is accessible to everyone. I've learned from my own mistakes in this space. I remember starting to use Number Talks with a Year 2 class in the last couple of years and over pitching. I thought that doing a dot talk followed by, say, 25 plus 18 would be a good place to start. I thought that surely that would be easy enough, and that was based on what myself and the teacher knew about the class. And it quickly became apparent that that was too hard. The responses that came out in that discussion were really long and convoluted, and it wasn't helpful for developing their number sense starting where they're at as a group. And one of the things that I did to get to know more about the students and where they were at was I just ran a week of small group number talks. And when I say a week, I mean over the course of 2 or 3 days. The students were set up with independent work, which was in the form of some creative maths puzzles that they played with. So quite quiet enough that I could work with a small group, but still playful, and that they would be engaged and we could minimise distractions. And I would just have 3 students at once, and we'd do a dot number talk that involved some 10 frames, and then we did an arithmetic talk, something like 9 plus 7. I wanted to see if they might make a friendly 10 in the strategies, and in some cases that came out. In other cases, the students are still counting all. So I learned a lot about what gaps there were, and that was super helpful at ensuring that the whole class number talks I was running, which by the way only take 5 to 10 minutes, they were accessible to those who really need those basic number understandings. And I think it's a common trap to over pitch our number talks, because they were created decades ago to help fill in the holes that that many students are leaving primary school with. So I think that's just really key to remember, that the extension in a number talks routine is that ability to communicate ideas with clarity so that the teacher can record those ideas on the board. It's making connections. It's attaching arithmetic to a solution. There are a whole bunch of other things that are happening.
And then where do you think, it may come unnaturally to others to identify where the explicit teaching is. Where would you say the explicit teaching is in number talks?
Actually, I read the other day an article which put it well. Explicit teaching is a cornerstone of teaching. You can't teach without explicit teaching, so it's something that's always there. But in terms of explicit teaching in mathematics, there is an excellent professional learning resource which is free. I don't even think you need an Edumail to sign up to it. I'm pretty sure I'm signed up with my personal account. But Alan Dugan from, I think it's AAMT, along with a bunch of other experts from different universities, work together. But they've come up with a professional learning resource that teaches what explicit teaching in maths is. And they've come up with 7 essential components of explicit teaching. It's a pretty nice way of illustrating that explicit teaching is just so much more than what many people believe it is. And so the 7 components are planning, super important, connections, feedback, dialogue, questioning, modelling, and learning needs. And then language is used to describe what each of these is talking about. So for instance, for dialogue, explicit teaching involves classroom dialogue that's focused on making mathematical ideas explicit.
Which is the cornerstone and the central part of number talks and maths talks, aren't they?
And really most maths instruction.
Yeah. And dialogue's very different to being talked at, isn't it? Dialogue is conversation. Yeah.
Exactly.
Yeah.
And then, the questioning is a huge one. This resource explains that, questioning is referring to teacher and student questioning that targets explicit concepts and processes. It's a really good resource. I recommend it. Yeah, in terms of really unpacking explicit teaching and what it means in maths, that's where I would suggest people head to.
Yeah. And the last one, and it came out in the explicit teaching there too, and we can probably make this question quite brief because I know you've spoken about it a fair bit already, but the planning aspect. I remember asking you whether there was a sequence or scope or resource that we can use that might help us to plan specifically and carefully what number talk we're going to use. Do you want to talk to that a little bit?
I think at the time I mentioned a book that I'd purchased. It's the Sherry Parish book, Number Talks, Whole Number Computation. And it has sequences of number talks. And actually, it might be worth mentioning that I consider a number talk to be a standalone problem that's quite juicy and that leads to a number of solutions that we can look at and make sense of. Whereas the Sherry Parish book gives you sequences, which is more about developing a particular strategy in a session. And it's suited for all years, but I guess it's particularly useful in the junior years because students are coming in and they really need help developing basic strategies. But it's got sequences of dot cards, sequences of number problems. Yeah, that's a book that's full of prompts. But also I will link to Dan Finkel's Number Talks post because he's got a whole bunch of prompts that he's designed to be run in sequence as well. So that in terms of somewhere to go for free, that's a good place. There's also some resources on the New Mathematics Hub as well, which I will link to.
Fantastic. Awesome. I'm feeling pretty full. How are you feeling?
Yeah, pretty full.
Doing most of the talking, so you're probably fuller than me. So let's move into our dessert menu. And then we've got a different kind of sign-off question for you today. Our dessert menu is, we've talked about it in every podcast. So what's your dessert menu choice?
I'm going to keep it short and sweet.
Yeah.
I picked Play It Forward, and my Play It Forward idea comes from a colleague who I admire for his flawless logic. His name is Professor Gary Steger, and he has a lot of lovely quotable lines. One of my favourites is that school has an obligation to introduce children to the things they don't yet know they love. He also has one universal rule for the classroom, and that's simply don't be a jerk. It's a simple rule that covers a lot.
Beautiful. I love it. Short and sweet too. Yeah. Which means we've got a little bit more time for the sign-off question, which is different today. So being that you are sort of the founder of 4 Sevens, and even though we're being very collaborative, the 4 Sevens means something to you. Do you want to explain and unpack the mystery behind the name of our podcast, 4 Sevens?
I read this beautiful novel called The Housekeeper and the Professor. The stories of a professor who has a housekeeper, and there's this whole complication where he only has 80 minutes of memory due to an accident. He has all these little note cards hanging off his suit to remind him of things that he needs to know about his life. But he hasn't lost his ability to engage in mathematics to high levels. And they have these informal conversations, it might be standing around the kitchen or something, and he'll just say, oh, when's your birthday? And then he'll make some connection between the housekeeper's birthday and something else that's really interesting about numbers, because that's his specialty, is how numbers behave. And there's one scene where he nudges or encourages her to play around with numbers and identify the factors of 28. Maybe we could have a go of doing that now. And I mean, like 1 obviously is a factor. 2, I think 4 is, because you can put 4 into 28. So we've got 1 plus 2 plus 4. 7 goes, 5's not.
Yep.
6 isn't. 7 goes into 28 4 times, as we know from all of the times we've solved that problem on this podcast. So we've got 1 plus 2 plus 4 plus 7. Can you find any more?
Well, 9 doesn't. No.
What if you halved 28?
Oh, yes.
So we've got...
So 14, yep.
So we've got 14 plus 7, which is 21.
Mm-hmm.
plus 4, which is 25, plus 2, which is 27, plus 1, which is 28. So there's this scene where she's like, oh, it adds up to 28. I wonder if that works with any other numbers. Then the professor gives her enough of a hint to say, oh, there is another one, that's before 20. But he also explains to her how incredibly rare and special they are. Because I think after 28, the next one is like 490 something, so they're these incredibly rare, beautiful numbers that behave in this interesting way where you add up their factors and it equals the number itself. And so that just really struck me, and it's the reason why the 28th of June has been coined the big day of maths play, because it's a particularly special date. And my favourite number is 7, so arbitrary. We needed a name for the podcast, so it was a little bit arbitrary, but it does have quite a special story behind it, in that the idea emerged from of a piece of literature that I loved and that I highly recommend to anyone who enjoys a good novel.
Yeah, and we both love reading, so it's lovely to have a book, particularly that creates mathematical thinking. Well, thank you so much, Alex, for coming on and taking some time out to talk to us.
Thanks for having me.
And we'll see you soon. We hope you enjoyed this episode of 4 Sevens. To access any of the resources mentioned in this episode, you can find links to these in the show notes. If you know someone you think would be interested in this episode, please remember to play it forward to them.
4 Sevens is produced by Maths Play and is a partnership project between Maths Play and motivating all maths learners to succeed. If you'd like to send us a message, you can do so at mathsplay.org/podcast.